Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Happy Sunday, everybody. Got the day right this time. How's it going? Hope everybody is doing well. I'm still rocking the facial foliage. We're not sure if we're going to keep it or not. And for those who have asked, and believe me, more people have asked than I would have thought. No, I won't be adding a beard to the logo because this is going to be a temporary transient kind of a thing. Um, so no, I don't plan on changing the logo anytime soon. For those who don't know, those of you overseas, and I see we have a few people here, we did the daylight savings time change overnight. So if you're thinking we're on an hour earlier than normal, um, to you, yes, we are an hour early. Apologize for any confusion. I didn't even think about it till this morning, and I thought, whoops, the time change is going to mess with folks. Well, we'll see. All right. Before we get going today, talking about the Fluting Toolpath, uh, uh, I need to give a few shout outs to a few people. Um, I get asked quite often if I can do one on one training or one on one tutoring, and I'm not in a position to do so. But I know a fella, and that fella's name is Bull Shanigan. He runs a tidy little ship over on Facebook. It's a group called The Make, and it's a great bunch of people. They get together, they swap ideas, uh, share files, and just do all kinds of real cool things, help each other, basically. And besides that, um, he also does one-on-one training with Vectric Software. So if you're new with V-carve or you're new with Aspire, he does one-on-one training, and he's very good at what he does. He is experienced as heck. He also has a website, bullshanigan.com. You can click that one-on-one training link. He does V-carve, he does Aspire, everything from the basics all the way up into and including 3D modeling and Aspire. He's getting into light burn. So he has one-on-one light burn training for those of you who have lasers. And he's just all around a good guy. Now, Steve, being forever on the job here, has linked both Bull's website and his Facebook group here in the chat. You'll also find links down in the description of this video. He's a friend of mine. Again, he does a very good job. He knows what he's talking about. He's been doing this forever, and he's more than happy to help you out one-on-one. The next person I want to shout out is the man I was already mentioned. We're talking about my friend Steve over at Harneal Media. Now, a lot of you are focused on starting a CNC business. You want to either create files, you want to create projects, you want to create products that you want to get out in front of the public at large. There is no better way to do that than with your own website. It will either create or augment your web presence and give an air of legitimacy to your business. And that is very, very important in this day and age. Also, as a side benefit, Steve will help you set up an e-commerce page and help you cut out the middleman who wants a piece of the action with every piece you sell. So I would definitely reach out to Steve, get over to harnealmedia.com. Again, he's very good at what he does. He is very reasonably priced, very competitively priced. That's 100% personalized service. When you're dealing with Harneal Media, you're dealing with Steve, and that's it. You're not talking to some nameless, faceless person in a call center that you'll never contact again. So I heartily endorse him. There's a link to Harneal Media in every video on my channel, and that's the case for a reason. So check him out, harnealmedia.com. Hit that contact us link on his page and have a chat with Steve. He'll square you away for sure. Okay, let's get into what's going on with the Fluting Toolpath. Whoops, that didn't mean to do that. I meant to mark it as a question for a little bit later on. Man. Let's see here. The thing about the fluting toolpath, first of all, what's a flute? No, we're not talking about the musical instrument. We're talking about the architectural element. Now, fluting goes back a long, long way. Nobody is really sure where it began, uh, but the Greeks made heavy use of it in about the 4th and 5th centuries BC. And you only have to look at Greek columns to see what we're talking about. And it doesn't matter if you're talking Doric, Ionic, or Corinthian, they made heavy use of fluting. This Doric column here doesn't happen to have a flute, but believe me when I say they put flutes on everything they could. Basically, when we're talking about flutes, we're talking about these vertical elements right here, where it has been relief carved into the surface of this column. That is transferred through the ages into wooden architectural elements, be they moldings, furniture legs, table legs, etc. But it's also spawned a little bit of confusion. Now, I don't want to be that guy, but I am that guy. In the strictest sense, we've confused fluting with reeding. R-E-E-D-I-N-G. This is an example of a fluted molding, meaning there is a concave shape being left behind after the carving. This, on the other hand, is an example of reeding, R-E-E-D-I-N-G, meaning a convex shape has been left after the carving. You can do both with the fluting toolpath. You could do either or both, and it's very simple to do. But even manufacturers get it wrong. That's not a fluted panel. That's a reeded panel. Here we have several more examples, and of these three, you could say these three here are fluted. These two here are definitely beaded. And we can argue forever about this because it's about 50-50. If you called that fluted, you'd be correct. And if you called that reeded, you would be correct. So it's kind of glass half full, glass half empty kind of thing. So that's the basics of fluting and reeding. And again, both of them are available to us using the fluting toolpath. The fluting toolpath over here in the toolpath tab, this icon right here, there are a lot of cases where it can be used for design elements, and it can be made to do things it wasn't actually designed to do. The main thing to remember about the fluting toolpath is while it will work on open vectors or closed vectors, it addresses each vector separately. So let's do probably one of the easiest flutes you will ever do. We'll just draw a vector starting here down to here with an open vector, just a straight line. And I'll close this and I'll come over to the fluting toolpath. Well, let me select the vector first. Then I'll come over to the fluting toolpath. Now, you'll notice there are no advanced options here. We're just going to enter a start depth, then we're going to enter a flute depth. And what that's asking for is the maximum cutting depth at the center of this flute. For this demonstration, I'll use a 1/4-inch ball nose bit. And then we have three types of flutes. We have a ramp over the complete length. So we can ramp that flute starting at 0 here, which is the start depth, and ending at 0.1 down here. So it's a gradual taper into the material. Okay. Excuse me. Then we have ramp at start. Now, that means just a ramp here at the beginning. So it will ramp down to our cut depth and then cut the rest of that flute at the cut depth. Okay. Then you have ramp at the start at the end. Okay. So it will ramp down however long you make your ramp length. It'll ramp down to that cutting depth, then cruise along at that cutting depth until it gets to this distance away from the end, then ramp upwards. Okay. Let's look at ramp at the start over a length of 1 inch. And I'm going to use a linear ramp, meaning it's going to come down in a linear fashion, just a straight angle over a distance of 1 inch. And I'm going to go ahead and calculate that. Now let me spin around here a little bit and we can see what that looks like. And again, the red line is a rapid move from 0. Then here's our plunge down into the material. And we can, if we look at it, we can kind of make out there is a little bit of an angle right here. It's not in line with this portion of our tool path. So let's slow down the preview a little bit, go about halfway, so we can see what this is going to do. And we can see that it went ahead and it started its plunge over a distance of 1 inch. And by the time it reached that inch, it's not, the plunge is finished, and now it's just going to take off and cut the rest of that flute. Then down here at the bottom, it got to the end, then retracted out and went back to 0. So that's probably one of the more basic type of flutes you could use. Let's go back and look at a couple of options. And we'll go into the fluting toolpath. Instead, we're going to ramp over the complete length. Now you notice when I ramp over the complete length, it grays out my ramp length. And now my only choice is linear or smooth. We'll get into these two in just a minute here. I'll recalculate. I'll reset my preview. And there's really nothing remarkable about the toolpath with the illustration here. So we'll just go ahead and we'll preview it. And we see what kind of effect that gives us there. We have very, very slight carving into it right here at the start, and it's gradually plunging deeper and deeper and deeper until we got down to our 0.1 cut depth down here. So that's a good start on the fluting toolpath. And you can create all kinds of effects with this. Let's jump out again, go back here, and we're going to ramp at the start and the end. And I'm going to shorten this length a little bit. Let's make it 1/2 inch from the ends, meaning it's going to start at 0, then plunge down to 0.1 over a distance of 1/2 inch. And I'm going to switch to a smooth ramp, meaning it's going to give this curved appearance with this flute rather than that straight linear appearance. So we'll calculate that. I'll reset my preview. And now there's something a little bit more remarkable about the appearance of this flute. We can see that it's going to wrap it up from 0, plunge down, and then kind of smoothly dip down over a distance of a 1/2 inch until it reaches our 0.1 cutting depth. Then at the end down here, when we get a 1/2 inch away from the end, it's going to start ramping back up, then retract out. So in looking at this toolpath when we carve it, we'll go ahead and preview it. We have a nice smooth ramp down here. Then we have a nice smooth ramp back in the center, boy. There we go. A nice smooth ramp up here. And that's simply by using ramping at the start and end, which generally speaking is the most common, and adjusting our ramp length. You can basically create a ramp length that's equal to the diameter of the bit you're going to be using. Okay? Making a ramp that is smaller than the diameter of the bit, while it will work, I have found that it doesn't look right. But feel free to play with it if you'd like. Now, fluting is most commonly associated with a concave shape, just a straight ball nose bit, but you're not limited to using a ball nose bit with this toolpath. You can actually create some pretty interesting patterns by, let's use a 90-degree V-bit, and trying for a little bit different of a pattern than just this straight concave. And I'm not going to make any other changes. Let's go ahead and calculate, reset my preview, and we'll zoom back out. And we'll preview that. So now we still have a neat flute, but instead of having that round bottom, it now has a V-groove shape to it. It's still a nice, smooth start here, and then a nice, smooth finish down here. And you can play with this. Again, it's not limited to ball nose or V-groove bits. You know, the only limit is basically your imagination. Okay, would be is saying, can you create a toolpath for a lamello biscuit through the fluting toolpath? Yes, you can. You certainly can. What you'll need to do is figure out a length, where you want that ramp to start, how much of a distance, how deep you need it to go. So it'll take a little bit of playing and a little bit of figuring out. And this is a great opportunity to practice in scrap. I mean, you could do this. You could cut lamello slots on a piece of 2x4 or an old fence board or something like that to get your measurements nailed down and figured out for each size. For those of you who don't know what a lamello is, what we're talking about a biscuit jointer biscuit. But yes, you certainly could do that. Okay, Sargon is asking, what about to do multiple passes for more depth? Well, that is up to the bit that you select. Okay, my preview selected's closed that. Let's go back into the fluting toolpath. Multiple passes for more depth. Okay, now I have a 0.1 depth here. Okay, if I go in and look at this particular bit, the pass depth is 0.108. All right. So what let's do, I'm not going to change the bit. Let's look at a flute depth of 0.25. So we're going to go pretty deep. And we'll use that same bit. We'll calculate. And now let's take a look at the toolpath. And we see it's going to make multiple passes. Okay. So you are, let's slow it down a little bit more because it is a fairly short toolpath. So you're going to come in, you're going to make your first pass, then come back and make the second pass. Oh, that's actually doing 3 passes. So that's all based upon the pass depth of the bit you're using and the depth you have set in your toolpath. Okay. So, but good question. And keep them coming like that. Let me go ahead and reset the preview. Bonk, bonk. Now, Bill Wallace wants to know, can you flute a cut that is on a circular arc? Yes, you can. Again, it will work with any vector, be it an open or closed vector. It's all in how you want to set it up. Let's get rid of this one here. And let's draw is that an arc? That's an arc. Okay, we're going to start here. We're going to come down here and we're going to pull you out like so. There we go. So we've got that circular arc there. We'll come back, go back into the fluting toolpath and do this. And I'm going to bring it down to 0.15. So it'll still need to do 2 passes. And I'm going to ramp at the start and at the end like I did. I'm not going to make any other changes here. We'll calculate. And we'll preview. And it's making its first pass. And come back and make its second pass. And again, it will follow any vector, be it circular arc, a straight line, a polyline, or a Bezier curve. All right, so you have a whole bunch of options that are opening up. Let me reset the preview here, close it, back to a straight Z view. In the case of what if we want a flute that is similar to this, it goes off the end of the material. Well, that's fairly simple as well. All we'll do is we'll draw our vectors oversize. We want to go at least the diameter of the bit we're going to use. So we'll start up here and we'll come down here. The reason we want to go larger than the diameter of our bit is because we want that plunge to take place off of the material so that it enters the material from the edge, not from the top. And close that, go back over. I'll use the same toolpath. I'll just change it. Let's see now. You could actually just use a profile toolpath for this. You don't necessarily have to use a fluting toolpath. But let's say we want to make this we want to ramp over the complete length. We want to start at we're going to start at 0.05. Now, 1 decimal point. Vectric doesn't like 2 decimal points. And we'll make that a quarter of an inch. Now let's leave it at 0.15. So it's going to plunge a total of 100 thou. And we're going to make it a linear ramp. It's going to ramp over the complete length of this vector. So we'll calculate that. Whoops, I got to select the vector, Mark. You've been doing this a week or two. Okay, we'll calculate that. And again, it's going to plunge. Well, it's going to plunge down here this time. And we'll preview that toolpath. And we see not only does it start and stop off of the material, but in this case, it started at the bottom and cut deeper here, then ended up shallower here. So can starting off of the material create tear out? Yes, it can. Okay. It can create tear out. Usually what I do in that case, it just depends on what I'm doing, Sargon. A lot of times if I'm doing something like this and I'm concerned about tear out, I'll make the material just slightly longer than I need and then cut out that tear out. If I absolutely can't do that, then I'll butt another piece up against it. Much like if you're using a hand router or a router table, when you butt that piece up against it, it tends to not chip out. The chip out will happen in that scrap piece. So there is that to take into consideration. Back to Z. I guess you hit the wrong one. So, I mean, effects can happen. You know, you can create all kinds of different effects using the toolpath. Now, Mike Mazalik has brought up an excellent point here. Just a note, overlapping vectors will cause problems. A figure eight of two circles or an X as an example. Yes, they can cause issues. Now, remember, as I said, the fluting toolpath works on one vector at a time. So let's go take this into consideration, what Michael is talking about, and we'll delete that and we'll create a circle here, close it, and I'll just center it side to side. Select that, hold down Control to copy, drag a copy down, and with geometry snapping on, I just snap it right there to the edge. So we have an overlap right there. Okay. Now we have two closed vectors, but we're going to go ahead and do fluting toolpaths on both of those vectors at the same time. Again, it's going to handle each vector separately. Okay. And we'll do the fluting toolpath and we'll do 0.1. So I'll get rid of that 5. Now, if we take a look here, we've got the green start point up here, the green start point here. That means it's going to start shallow here. It's going to start shallow here. So let's take a look at what we get. I'm not going to change. Yeah, let me ramp at the start and we'll bring that in for 1/2 inch. So we see what that looks like. And I'll keep it linear. We'll calculate. And now we'll preview. And it's going to start with the bottom one first. Now, first we can see the problem it caused by using a closed circular vector. We have a real shallow start here and no liftoff. So technically that should have been a ramp at the start and the finish. But more to Michael's point, if we take a look at this down here, we have pretty much a mess where this deep carve overlapped with this shallow carve and then met with the deep carve again. So there are various problems in there. Now, if you want to get in and sand that out, be my guest. But we have a depth here of approximately 0.0945, and we have a depth here of 0981. So we're going with different depths, 0.877. We've got a bunch of different depths here. So that's not the look that I would go for. It's not the look that I'm looking for. Just know that overlapping vectors can create an issue. Let's delete that one. Let's go back over and we'll draw draw a cross here, or an X rather. And let's get 45 degree. Okay. And we're gonna wake that one up. We'll come here and we'll come down here 45 degrees. That's good. All right. Now let's close that. Come over. We'll go into this fluting toolpath here. And we're going to do start and end to make it look a little nicer. I'm not going to make any other changes. Just calculate and see what we get. Couldn't you move the start points away from the overlap? Yes, I could. And that's a very good point. However, it still creates the issues where those points meet. Let's take a look and see what happens with this one. Basically, it's the unpredictability of the situation. Now, this one looks like it's going to do okay. And yes, it did. That one worked out just fine. That looks just fine. Just know that it can create issues. There can be slight differences in depth. There can be chip out and break out on some of these points. But this is a case of experiment and see what's going on. Just check it out. So it may work perfectly. It may not work perfectly. That's all I'm saying. Let's close that. Can you not use a ramp? You cannot use a ramp, but that's a profile toolpath. The whole point of the fluting toolpath is that ramp. If you didn't want it to ramp, for instance, let's go back to this example back here. We'll delete these. And I'll make a straight line that starts here, comes down here, and then we'll make another straight line, starts here, goes down to there. Okay. And we're going to do the fluting toolpath on this one, ramp over the entire length. And yeah, I'm going to leave those alone. Okay. But I'm not going to preview that. If you didn't want a ramp, use a profile toolpath, and we're going to start at, what was that, 0.05 and go down to 0.15, and we're going to cut on the vector. I'm going to select the same V bit, select, cutting on the vector, and then we calculate. Did I make a mistake with my vector? Yes, I did. Okay. Let me go back into my profile. I need to bring that up. All right, what am I doing? Boy, let's close this. What am I doing? Control, or let's select this one, go into node editing. We'll get there. Boy, I horked that up. Let me go back over here. And wait. Uncheck. That's what I'm doing. All right, there we go. Nope, I just moved it. I didn't lengthen it. Let's drag that down there. Okay, I moved my vector. I didn't lengthen the vector. That was what the holdup was. All right, there we go. Now I have that correct. And we will calculate that. That's better. Okay. Now we'll preview all toolpaths. And there I have the ramp. And here I don't have the ramp. Okay. So if you don't want that ramp, you would use the profile toolpath. Okay. The main feature of using the fluting toolpath is that ramp. That when that is desirable, you would use the fluting. When it's not desirable, you would use the profile. So hope that helps there, Dan. Never mind all the mistakes I made along the way. Now, I have another sheet over here to show you something else. And this has been the cause of quite a few questions that I've had. And that is about using the fluting toolpath to do a ramped in, basically to hollow it out. How do you make that ramp wider? And this is what I mean when I say a fluting toolpath works with one vector at a time. Okay. To make a wider flute, you have two choices. One is to use a larger bit. So in this case over here, the way I would make this wider would be to use, instead of a 1/4 inch ball nose, use my 1/2 inch ball nose. And that would make that flute wider. If I needed wider then, I could move on to a 3/4 inch ball nose or core box bit. Or I could move to a 1 inch or 1.5 inch. That would give me that nice smooth concave that I'm looking for. And I could adjust the depth to suit. Well, what happens if I use 2 vectors? Well, if I use 2 vectors, the problem then becomes the cusp down at the bottom of that flute. Because you have a round bit carving, then you have a vector next to it carving. You're going to have that point where the two tips meet. And that's what's going to give you this pattern here on a much smaller scale. Now you can do it, but you're going to need to use a lot of vectors. seriously a lot of vectors. Now it can work. There are a couple of issues though, and we'll get into those right now. Also, you don't have to use a ball nose bit. You can use a standard end mill. So that's where this sheet comes in. Let's go ahead and get over here and let's create a rectangle. And I'm going to make that width in X. Let's make it 8 inches wide. And let's make it 3 inches tall. And I'm going to anchor the center on my X0, Y0, and we'll create it. Okay, so I've got my rectangle here. I can use this rectangle, but it's going to follow the perimeter. Well, what if I want to ramp this entire section down? Can I do that? Yes, I can. I can use a standard end mill, but what I'm going to have to do is I'm going to have to create vectors from side to side. Okay? Can't you just use a bowl bit? Certainly. Yes, you certainly can. But let's say in the sake of this, I want square sides. I don't want that radius. I want square sides along the edges. I can cut this out. But again, I'm going to use a couple of vectors here as a demonstration. What I'm going to need to do is I'm going to have to come down. I'm going to use a guide for this. So, oops, come on. Oh, I'm within that. I can't drag a guide. So I'm going to put a guide here, and now I'm going to move it down. I'm going to use a 1/4 inch end mill. Okay. And so I need to take half of that. Half of a quarter is 1/8 of an inch. So I'm going to, because I'm making a negative move, I'm going to say minus 0.125 equals, and I'll apply it, and that close, and that's where my guide is. Now I'm going to come back, and I'm going to draw a vector right there. Nope, get down here. There we go. No, not there. Right there on that intersection. Then I'm going to zip over here and draw it right there. And spacebar to accept that line. And I'll delete that guide. I no longer need it. So I now have a vector here. I want to carve out this entire area here. So I've got a 3-inch wide piece, and I've got a 1/8 of an inch radius of my tool. So I'll select it, and I'll come down here and create a linear array. Now, I want columns in Y. I do not want columns in X. I'm not looking to move over this way. I'm looking to create them down. So I want one column in X. Now, I'm sure there's a way to figure out exactly how many of these vectors I'm going to have to place 1/8 of an inch apart times 3. So let's take 8 times 3 and call that 24. So I'll go with 24 columns in Y, and let's see what that does. 3 inches wide, 8 per inch. 8 times 3 is 24. I'm going to put a gap, nothing in X, a gap of 0. I'm going to put a gap of 1/8 of an inch in Y. Because I'm starting at the top and moving down, this is a negative move, excuse me, that needs to be negative 1/8 of an inch. So it's going to create 24 more vectors down this direction. We'll click copy, and there we go. Well, I could have done 23. I don't need this last one here. Hold down Shift, deselect my rectangle. Then I can hit delete, and that deleted that last one there. So now I have all my vectors. I can go right here to right here, select all of those, come over to my Fluting Toolpath, and make sure that all of my start points are at the same end. Okay. I want to ramp over the complete length. I want it to be linear. I've got my depth, 0.15. We'll calculate. We can see what the bit is going to do. Now I'll preview that. And I made a mistake. Stop. Reset the preview. I didn't change my bit. Hello. Let's go back to a 1/4 inch end mill. There we go. Select, calculate. Now we'll try that. Let's preview. There we go. That's better. Okay, and we see what it's doing now. It's starting up here and it's gradually sloping down. Okay. Now this does work. It works very well, but there are two problems. I don't know if you can see. I'm going to try to get this into a position that you can see this. But we have two issues down at this end. My sides here are nice and straight. But now I have a flat spot right here where these tool paths ended, because again, we're dealing with a round bit. I also have a jagged edge here where all of these cusps met, where all of this was left behind because of the radius of the bit. Now that happened because I used a spacing of 1/8 of an inch, half the radius of the bit. Now you can pack these vectors in tighter. Instead of 24, we could go with 48. We could go with 96 and really jam these in here together. And it may work, but that's a lot of step over, or that's a real fine step over. Well, let's go ahead and give it a try. We'll close that. Let's go back, and I'm going to Control Z until I eliminated those. And I'm going to zoom back in to this one here. And let's double, let's just go to 48 instead of 24. I want to move this down now to, I'm going to make it a 1/16 of an inch. Minus 0.0625 equals, we'll apply that, close, and now I can move this vector right up and snap it to that guide. Close, then I can delete that guide. Now I can select this. We're going to go with 48. Nope, we're going to go with 47 because I don't need that last one. So we'll go 47, and we're going to change that to negative 0.625. Copy. Close. Now with them all selected, I'll probably have to reselect, and I did. Hold down Shift and select all the rest of these. Start points are all in the same place. Calculate. Now let's preview. Stop. I didn't reset my preview. There we go. Now let's preview. So we're moving over by smaller increments each time. And that we're still going to have this cusp down here on the end. We're still going to have the flat spots, but it's going to be less and less obvious the closer together we put those vectors. But my point in this being that you're going to have a flat spot because you're dealing with a flat end on that end mill. And you're going to have these cusps because you're dealing with the radius of the bit. Now we could tighten this up again so that we have 96 instead of 48 vectors. And you can keep going, basically until the cows come home or until these cusps are so small you really don't see them. Now, machined in wood has a very good point here to be made. You can put an L at the end of those vectors to reduce the cusping. What he means by that is, and it's an excellent point, it's a great tip. We've got this figured out that these little cusps are going to be approximately a 1/16 of an inch apart. So if we go back to our vector, let's reset the preview so I don't do that again. We go back over here, Control Z. We take this vector right here. And let's see, we'll just go ahead, we'll add, start right here on the end of that vector, and we'll come down. Let's go, see, we're going to come down about a 1/16 of an inch. Let's 0.0635. That's good enough. That's a little bit more than a 1/16 of an inch. Close. Now I'll select these two vectors, hold down Shift and deselect my rectangle so I don't have that. And then I'll want to join. I've got two open vectors. I want one open vector. There we go. Close. And then I'm going to have to modify the one on the bottom after I do this array, because otherwise I'm going to have a vector sticking out down here. Okay. So we'll go to the array. I'm not going to change anything. We'll copy. What did I? Oh, whoop. Control Z. I need to come back in and have that because I added. So we're going to go with 03125. Copy. And it's still too many. But come down here and we'll delete these. Delete this one. Whoops. Yes. And now this one here, I'm going to node edit, go in, and I'm going to delete that span. Well, actually, I can delete that entire vector. I don't need to do that. Never mind. I can delete that entire vector. It's not necessary. Okay, now let's close that. Go over, close the preview, go into the toolpath. Select all of these, calculate, and now let's preview. See how it's making that little hook right there? Just kind of making a little bit of a hook right there. Yeah, I need to put one more straight vector down at the bottom, but you get the point. Putting that little hook in there, as machined in wood pointed out, it eliminated that cusping. It didn't eliminate this flat spot. Not at all. but it did eliminate that cusping. And I would need to put a another straight vector down in here to get closer to the edge of my rectangle. But you get the point. There need to be a little bit of playing around with this design, but that's all based on the fact that there is no cleanup pass that you can really do here, unless you want to do a, you could put a vector down here, say 1/8 of an inch in, and get it set to absolutely 0.15 deep and do a profile toolpath to kind of come back and clean that up, cutting on the vector. But there are ways around this. There are ways to make it work for you. Let's see, what are we looking at? We're about an hour in. Now, I'm going to go ahead and do one. I'm going to make another sheet over here. We're going to do one more example of something because there are a few cases where, when am I going to use this in real life? Well, I'll show you. Let's do a cutting board. So I'll just go ahead and call it sheet 3. I've got that sheet selected. Let's edit it. And we're going to make this board 12 inches high. Let's make it 20 inches wide by 12 inches high. And we'll make it 2.5 inches thick. So we've got a nice cutting board here. All right. Go back into my drawing tab. Now I want to make a juice groove. Well, juice grooves are fairly simple. If you are just making just a standard juice groove that's going to catch everything, you don't need that ramp. You don't need the plunge. What you're looking at then is simply drawing a rectangle. I'm going to go 0, 0, and let's make it 1 inch narrower than the board in X and 1 inch narrower in height, 1 inch shorter in height. Okay. So we'll go X minus, now let's make it 2 inches. I wanted an inch in. So X minus 2 equals, and Y minus 2 equals, centered on my X0, Y0, create, and there's my juice groove. Now, if I don't want any taper in this juice groove, I just come over and select it, and I'll do a profile toolpath. Let's cut it 0.25 deep. I'd probably go a little deeper than that. And I'm just going to use my 1/2 inch ball nose. And I'm going to cut on the vector. It's going to do it in one pass. I want to make sure I get sharp external corners. I don't think I'll ramp it in. This bit can handle it. We'll calculate that. And there is a juice groove. That's all well and good. That's going to turn out nice. That's a cutting board that I'd be proud to make. No big deal. But let's add a couple of details here. Let's come back to my cutting board. And let's say down at this end, I want a little well. I want to taper these sides here of the juice groove. And to channel all the juices down into a little well here. So what I'm going to need to do is I'm going to need to pocket out a well. So let's start with about right here and go to about like so. We're going to change that. I'm going to anchor it here on this corner, and I'm just going to make it 2 inches even. And we'll apply that. So I've got about a 2-inch well here. Okay. Now, when I go to make this juice groove, I've got to remember that I'm using a 1/2-inch bit. So what I'm going to have to do is take that into account so that the edge of this juice groove isn't out here and my well is down here. So I'm going to go ahead and make this just a little bit taller. And I'm going to anchor it at the center. So let's go with 11 inches tall. All right, now when my juice groove gets cut, the edge out here will be inside this well. Okay. Now I have other things to concern myself with. I want these two sides to taper, but I don't want this top to taper. So what I'm going to have to do is, you're not going to like this, but what the heck? This is where it comes into. I'm going to copy this rectangle to another layer. I'm going to copy it to a new layer, call it layer 2, and we're going to make this blue, make it a lighter blue so that we can see the difference in color on the monitor. Then I'm going to click OK. Now what I'm going to do with this is go over, make layer 2 active and turn off layer 1. I'm going to select it, go into node editing, and I'm going to delete that span. And I'm going to delete this span. Okay. So now I have 2 separate vectors. Now I need to be careful and take a look at my start points. My start points are over here. I want to taper this way. So I need to make these my start points. Make start point and make start point. That way we'll start at my cut depth here and we'll work our way down. Okay, so now I can come out of node editing, go back, turn on layer 1, make layer 1 active. And I made another mistake. So, and that mistake is my rectangle here is the same, is going to end right here on this end of the well. It doesn't need to do that. In fact, it needs to end somewhere in here because there's no need for this fluting toolpath to go all the way over here. So let's put that into move and transform mode, go about like so, and that's good enough. Now I'll go into node editing again because there's no reason to let this cut air right here. I'll delete this span. Again, my start point's here. I'm going to bring it down to here. No, come on. Make start point. Well, let's see, let me turn off my other vector. Turn off layer 2. And this is one of the reasons why I use layers so much, is because I could not select this point without it interfering with the other. Now, why is it not letting me make that a start point? What is going on here? I can make that a start point. I can't make you a start point. No, because it's an open vector. That's why you can't make that a start point. Okay. Exactly. It's an open vector. But that's okay, because the way I'm going to treat this, I'm going to treat it a little bit differently than I would never mind. I just confused myself. All right, let's bring back layer 2, because now I need to shorten these because I did the same thing. So let's grab hold of this, drag it to the same distance, grab a hold of this, drag it to the same, snap it to the same place. Now that I have you totally confused, we're ready to calculate some toolpaths. And I know you're saying, what the what? Well, let's do it. We're going to reset the preview. We're going to close this, and we're on sheet 3. I shouldn't have. Oh, yes, I should have. That's right. I'm going to go ahead and delete that toolpath. All right. Select this, and I'm going to do a pocket. I'm going to cut that little well down there, and I'm going to make it 0.5 deep. And I'm going to use a 1/2 inch end mill to cut that pocket. Select, and I'll go ahead and do offset because it is a round, more or less, pattern. And we'll calculate that. And that's going to cut the juice well into the cutting board. And this can be kind of a harrowing experience if you put a lot of work into making an end grain cutting board. Trust me. Get it all nice and pretty and sand it up and ready to go, and then cut a big hole in it. All right. So we've got our juice well here, and it looks pretty good. Well, now I'm going to take the rectangle here, and I'm going to create a standard 1/4 inch juice groove. That's going to do 2 things. That's going to give me a start depth up here. It's going to give me a straight groove right here. It's going to act as kind of a clearance pass for this, for these 2 sides, my flutes. So close that, and I'm going to use a profile toolpath, again cutting on the vector, again using my 1/2 inch ball nose, and I'm going to go for a 1/4 inch depth. Okay, and we'll calculate that, and then we'll preview it. So my juice groove ends up here inside this well. I could adjust things, make that a little bit smaller so that this edge, it looks like it drops straight down along with this edge. But I think I prefer this. Now I'm going to close this, go back into my 2D view, and I'm going to open up the flute. I'm going to deselect everything. I'm going to open up the fluting toolpath, and I'm going to start my start depth 0.25 because I want it to start in that flute that I've already cut, in that groove that I've already cut. And I want to make that depth, I'm going to make it 1/8 of an inch. So the end of the juice groove is going to be 3/8 of an inch down from the surface. I'm going to ramp over the complete length. I have no vectors selected out here. I'm going to do a associate with toolpath. This time I'm going to select the open vectors on layer 2. And I'm going to associate it with the toolpath, close, and now these will start down in that juice groove and cut another 1/8 of an inch down that ramp over the entire length. calculate, and we'll preview. And I didn't change the bit. Undo last. Let's go back. I used my 1/4 inch end mill, used my 1/2 inch ball nose, select, preview early, preview often. Now we'll preview that tool path, and we see that it made 2 nice round bottom flutes down into this well. They're the same width all the way across. They don't taper outwards. But now I have a tapered channel that runs down into this well. Eighth Center says, to make this practical, you should really split the left line into 2 and flute them so they both run towards the channel that then runs into the well. You can do that. And what Eighth Center is talking about is you would split this rectangle into 2 open vectors right here and kind of extend both of them so that they overlap, so that the juices run down here this way and then down here. And you can do that. I personally don't like that look, but it's 100% up to you. And the reason I say I don't like that look is what you'll find is up here at this end where these 2 meet, your flute is going to be narrower because it's using less of that. I'm using my hands like you can see me. Your flute is going to be narrower up here, right where this intersection is, because you're using less of that ball nose bit to cut shallow. It just, to me, it looks odd. And let's remember how water flow works. You're not trying to eliminate 100% of the juices that are in this channel. You're trying to channel excess down into here. So it's going to, as it's flowing this way, it's going to draw the juices out of here because water is going to take the path of least resistance. So rather than building up here, it's going to flow up the shortest path to get down into this area here. So, you know, basically that's what I'm getting at. Now, if you're not much for the 1/2 inch, I can change that up a little bit, make it a little bit wider because that is pretty deep. You got to admit. So let's reset the preview and I'm not going to touch the pocket. That's going to be fine. For the profile, I'm going to swap out the ball nose for my 3/4 inch bowl and tray bit. Select that. And then we'll calculate. Then for the fluting, I'm going to use the same bit. I'm going to switch over to my 3/4 inch bowl and tray bit. Select that. We'll calculate. I got nothing to add to that. Okay. I got nothing, Sargon. That's civil engineering storm drain design. Yeah. Okay. I've changed the bit for these 2. And now we'll just go ahead and we'll preview all tool paths and see what we get. And here's hoping I didn't make a hash out of the whole ding dong thing. And again, this is why I say preview early, preview often. And if it doesn't look right in the preview, it's not going to get better when you go out and start cutting material. Okay. And there goes my, for all intents and purposes, clearance pass. And now there is, okay, my cut depth. I needed that one. Now there is my taper. There is my other taper. And now we have that. So you've got a wider channel and things are going to drain down through this cutting board into this well here. If you really, really want to get fancy, one could draw a vector from, say, here. Well, just draw a vector at a 45-degree angle right here at one corner. Use this same bit on a profile toolpath, cutting on the vector, and make a little pour spout. We can go ahead and we can preview that. Let's draw a line, let's say from about, let's say here. We're going to go 45-degree angle to about, let's go about the middle. And yeah, that's about right. Okay. So I've got that vector there. Close. No, technically that should be longer than that. It needs to be at least the radius of the bit. And we'll make that the start point. And okay, we're good there. Come over here. And with that selected, I'm going to do a profile. And yeah, I'll go with 1/4 of an inch. And I'm going to use the same bowl and tray bit. No, I'm not. I'm going to use my 1/2 inch ball nose. Select. And carving, again, carving on the vector. Calculate. And how deep did I go? Yeah, we'll do that. And there's your pour spout. Okay. Scrape the juice off into the sink with a carpenter scraper. Well, you could do that, you know. So I'm sitting here trying to turn this on a different screen. It just all depends on how fancy you want to get. Now that actually should have been lined up with the corner here. Should have been the corner from the inside of the pocket to the corner of the cutting board. But that's why you preview. If you don't like it, you change it. But there you go. You can get as fancy or as plain as you want to get. But I will say that a lot of it has to do with this fluting toolpath in making tapers or clearing out pockets, or just simply put, creating decorative flutes and reeds. For example, I didn't get into it. We're running low on time because I have a few questions over here I want to answer that aren't on the fluting toolpath. We could take a 1/4 inch roundover bit. It's going to have a 1/4 inch radius. And we can create vectors a 1/2 inch apart. And we're talking a point cutting roundover bit. And we can use either profile toolpath or a fluting toolpath to create that reeded surface. So if I come over here, let's close this, shoot over here. And I will get to I promise I'll get to your questions in just a minute. Here I want to go with 4 columns in Y. No, 1 column in Y, 4 columns in X, and I want to space them. We're moving to the left, so that's a positive move. 0.5 apart. Copy. Where did we go? Where did we go? Oh, my offset in Y. That's why. My offset should be in X. That should be 0. And we go at 0.5. Now let's try that. Oh, that works so much better. There we go. So I can take these vectors here and either use a fluting toolpath, or I probably would use a profile toolpath for this now that I'm thinking about it. Yeah, let's do that. Number one, let's move those over off of my original. And I would use a profile toolpath for that. And I'm going to make them a 1/4 inch deep. I'm going to select my 1/4 inch round over, point cutting round over bit. Select on the vector. And okay, ignore the duplicate vectors. And preview. Let's speed this up. There we go. And there we are. We have a reeded surface using the profile toolpath and a point cutting round over bit. So there we go. That was kind of outside of the scope of the fluting toolpath, but the point remains is that the fluting toolpath can be used for various details. It can be used, to again create flutes and beads. It can be used to clear out large pockets, and it can be used for creating tapers in other elements that you're already using them. Now we're just kind of scratching the surface, but somebody commented up here that this would be good for a marble machine. Marble run, yes. Bill Wallace, this would be good for a marble run. It would absolutely be good for a marble run. And it just depends on where you want to go, where you want it to go, and how you want it to get there. So let's go ahead and get into these other questions, and I apologize for taking so long here. Okay. David, Vortex 8 wants to know, how is one to determine the high-low point of a piece of material on a machine when trying to establish the Z0 for flattening? That can take many forms, David. Probably the most basic way is with a ruler or tape measure. Figure out where that high spot is as close as you can, and use that as a baseline, pretty much. Excuse me. It's another way of doing it is to place a bit into the spindle and just jog the machine around. And if you get close to an area, you can kind of figure where that is by looking at your DRO. There are a lot of ways of doing this. And as far as figuring the low point, finding the high spot is easy. Finding the low point is kind of iffy. What I tend to try to do is find the highest point, and if I'm off a little bit, it's okay, because you're going to be surfacing down at least to that low point, probably past it. So finding the low point is less important than finding that high spot. And even if you do kind of miss the high spot, if you set your Z0 and you find that there's another high spot that's 30 thousandths of an inch or a 1/4 millimeter above that, it's not much. It's going to take it off. And I see some other suggestions here. Use a level or a dial indicator. You certainly can do that. But I find that when I'm, roughing a slab, I just kind of pass my surfacing bit over it and watch. And when I see that bit is over an area where it's, getting close to that bit, I'll take a look at what's in my readout, or even zero my readout, and then start looking for that lower point and find it. And it doesn't have to be the absolute lowest, but just if I see that I'm going to have to take 1/8 of an inch of material off to at least get down to that lower point, then I know that I'm going to need to remove 1/8 of an inch of material in my example. Generally speaking, when I do when I'm surfacing material, I have two tool paths that I use. I'll create a rectangle that's approximately the size of the material, just a little bit bigger than the material. I surface in my Y direction. So I make that rectangle a 1/2 inch wider on each side. So a total of 1 inch wider than the material. And then my surfacing bit is 2 inches in diameter. So in Y, I make that rectangle 5 inches taller than my material. That way, all of my X moves, when it moves over to do the next pass, are done off of the material. So it will run, let's say it starts up here, it'll run down here, come off of the material by 2.5 inches. So just a little more than the diameter of the bit, then move over, then go back this way, and so on until it's gone over the entire piece. I want it to go off of the material by a 1/2 inch on each side. So I make the rectangle 1 inch wider. That will cover the entire piece. Okay. I make two tool paths, one of which I'm removing 20 thousandths of an inch, so 0.02, and the other one I'm removing 10 thousandths of an inch, 0.01. Those are the only two tool paths that I'll use. I do the rest of it with my control software. The first pass, I take 20 thousandths off. If I need to go more, I do it again, and I do it again, and I do it again. It sounds like it takes a long time, but if each pass is taking 35 seconds, Now, if I have to take down a large amount, if I'm taking off a 1/2 inch material or more, then yeah, I'll make deeper passes. But, and it also depends on your bit. My bit, the manufacturer recommends taking off no more than 1/8 of an inch per pass. I don't get anywhere near that. Just simply because I take it easy on the bit, I take it easy on the material. I don't know how the material is going to react. So I go in 20 and 10 thousandths increments. So basically, when you're surfacing material, finding the exact highest point is less important than you really think, because it's going to get removed. So let's see here. Okay, I see Gene asked the same question twice. In the stack text part 1, you made a rectangle using the Alt key. Why not use the draw rectangle? You certainly can. I don't remember using the Alt key. And in fact, I don't remember. I can't think of a way to make a rectangle using the Alt key. Maybe I use the Control key to copy a rectangle. But maybe I used a keyboard shortcut to get into draw rectangle. But you certainly can. The point is to draw a rectangle. And however you do it is the right way. If it gives you the rectangle you want, you did it right. Okay, let's see here. Okay, and that is it. That is all the questions. Let me see here. Machinedom Wood says, if you have a probe, you can probe the entire surface. Open the data in Auto Leveler, and it will show you a quote-unquote heat map of relative heights. Yeah, you can do that. You can also, let's see here, maybe a level or a dial indicator. You can certainly use a dial indicator. You can use calipers. You can use various methods. If you have a way of mounting a dial indicator to your spindle, you can just pick a spot and set your dial indicator to 0, and then move it around and find that high spot, watching your needle. Personally, I have never found it to be that necessary. If you're dealing with something that was cut with a chainsaw, placing that bit over what appears to be the highest area and kind of moving it around until you have found that highest area, then bring that bit down to just touch. Check your DRO, and that'll give you your thickness. I guess I should have said set your Z0 to the machine bed, then jog it over, and it will give you the thickness at that highest point. Just nudge it down to where it just touches that high point, and that's going to give you your material thickness there. But I haven't found it to be that, I haven't found a need to be that precise. So, okay. Yeah, I'm going to go ahead and wrap this one up. We went a little bit overboard. We can go further into the fluting toolpath, but I don't know that necessarily speaking, it is true, or it is necessary. Basically, the thing to remember is if you want to make a flute wider, you have two choices. You can either use a larger diameter bit, or you can put a lot of vectors really close together in that area. So, let's see. 8 Center says, if you can't edit the G code, you can set your Z height by placing your probe on stacked paper. And then, well, I get what you're saying. Place your probe on stacked paper, remove the paper cut, etc. You can do that, but what I do is I cheat. Now, I use Mach 4 as my controller software. And when Mach 4 is finished running the toolpath, it lifts up and goes back to the home position. Spindle shuts down, and Mach 4 tells me that for the sake of argument, my home position, my bit is 1/4 inch above the material. So it says my Z height is 0.25. If I want it to go down another 20 thousandths of an inch, I'll click in my DRO and I'll type in 0.27. Then hit enter, and now the machine thinks it's at 0.27 and not 0.25. Then I hit cycle start, it's going to drop that 20 thousandths, go over and recut the thing. So I'm only using one piece of G code. I'm not editing that G code at all. It's just when that pass is done, if I need another pass, I tell it that it's actually sitting higher than it actually is. So it'll adjust down and then go back and make that cut. All kinds of little sneaky tricks. I want to make a video on that. I just haven't yet. And I don't have a piece of material I need to surface in order to make that video. So, but to wrap up, if there are any comments, questions, concerns, anything you want to know about, well, anything on my channel, let me know. And I'll do what I can. Next week, I'm not sure what I'm wanting to do yet. Lots of stuff going on behind the scenes. We'll see what happens. But give me your suggestions. What would you like to talk about? What do you want to see? Channel members, I have something coming up involving the engraving toolpath tomorrow. Very little, but we're going to talk about the engraving toolpath and find other ways of creating something within that you would think the engraving toolpath would work for. If you don't know what the heck I'm talking about, or you want some information on becoming a channel member, click that little join button down there next to the subscribe button. A panel is going to pop up and a video is going to play that'll tell you all about channel membership. Okay. So for everybody else, next Sunday, I'm scrolling through the Rolodex in my brain to make sure that I've talked about everything I wanted to talk about today. I'm sure something will come up when I get back in the house and go, ah. Don't forget to change the clock out in the car too. That way, you don't end up showing up an hour late. Other than that, yeah, have a great rest of your day. And relax. Relax. It's going to be all right. Breathe in, breathe out, move on. This too shall pass. Y'all have a great week. Y'all take care. Thank you.